Aircraft carriers are among the most impressive and powerful machines ever built, serving as floating cities and mobile air bases that project military strength across the globe. Did you know the largest aircraft carrier is longer than 3 football fields combined? These giants don't just dominate the seas, they redefine naval warfare and global power projection. Ready to discover which carriers hold the crown as the biggest and most formidable? Let's dive into the top 10 largest aircraft carriers in the world. Do you know which one leads the pack? USS Gerald R. Ford, CVN-78, United States. USS Gerald R. Ford isn't just another aircraft carrier, it's a floating marvel of modern engineering and honestly the largest warship ever built. Stretching an astonishing 1,106 feet long, this colossal vessel displaces around 100,000 tons, making it a true giant on the seas. What sets the Gerald R. Ford apart isn't just its size, but the cutting-edge technology packed inside. It features an advanced electromagnetic aircraft launch system, replacing the traditional steam catapults, which allows for smoother and faster launches of fighter jets. This means more sorties, more power, and greater efficiency during missions. The carrier can carry over 75 aircraft, including the latest F-35 fighters, helicopters and drones, making it a formidable force in any naval operation. Beyond its firepower, the Gerald R. Ford is designed for improved crew comfort and reduced maintenance, with innovations that cut down the number of sailors needed to operate the ship. This not only reduces costs, but also makes it one of the most advanced and sustainable carriers in the world. The ship's nuclear reactors provide virtually unlimited range and endurance, allowing it to stay deployed for months without refueling. Every inch of the USS Gerald R. Ford screams power, innovation, and dominance on the ocean, symbolizing the cutting edge of naval warfare and the future of aircraft carriers worldwide. Whether it's launching aircraft or serving as a mobile command center, this ship is a floating fortress that really redefines what a carrier can be. USS Nimitz, CVN-68, United States. When it comes to aircraft carriers, the USS Nimitz class stands as a symbol of enduring naval power and unmatched capability. Measuring about 1,092 feet in length and displacing roughly 97,000 tons, these nuclear-powered giants have been the backbone of the U.S. Navy's carrier fleet for over 4 decades. What makes the Nimitz class so remarkable is not only their sheer size, but their ability to project power anywhere in the world with incredible speed and efficiency. These carriers can support a massive air wing of over 60 aircraft, including fighter jets, electronic warfare planes and helicopters, giving them unmatched versatility in combat and humanitarian missions alike. Powered by 2 nuclear reactors, the Nimitz-class carriers can operate for over 20 years without refueling, allowing them to remain on station for extended deployments. Inside, the ship is a bustling city at sea, with thousands of sailors working in perfect coordination to launch, recover, and maintain aircraft around the clock. Despite their age, these carriers have undergone continuous upgrades to stay at the cutting edge of technology, incorporating advanced radar systems, improved weapons, and enhanced flight deck operations. The USS Nimitz and her sister ships represent a perfect blend of size, endurance, and firepower, making them a formidable presence on the world's oceans. Their legacy is not just in their impressive dimensions, but in their ability to adapt and dominate, proving that sometimes, size truly does matter when it comes to naval supremacy. INS Vikramaditya, India. India's INS Vikramaditya is a striking example of transformation and resilience in naval history. Originally built as a Soviet-era Kiev-class aircraft carrier, this massive ship underwent a remarkable makeover to become the flagship of the Indian Navy. Stretching about 930 feet long, the Vikramaditya displaces around 45,000 tons, making it one of the largest carriers in Asia. What makes this carrier truly fascinating is how it was extensively refurbished and modernized, turning an aging warship into a state-of-the-art powerhouse capable of launching a diverse air wing of around 36 aircraft, including MiG-29K fighters and helicopters. The ship's flight deck is designed for ski-jump takeoffs, allowing aircraft to launch without catapults, which is a unique feature compared to some other giant carriers. Beyond its impressive size and firepower, the Vikramaditya plays a crucial role in India's strategic defense, projecting power across the Indian Ocean and beyond. Its transformation from a Soviet relic to a modern naval asset showcases India's growing maritime ambitions and technological prowess. The carrier also serves as a floating city, housing thousands of sailors who keep the ship operational around the clock. With its blend of history, modernization, and strategic importance, INS Vikramaditya is more than just a ship. It's a symbol of India's naval strength and evolving role on the global stage. Liaoning CV-16, China. China's Liaoning aircraft carrier marks a significant milestone in the country's naval ambitions, standing as a powerful symbol of its growing maritime strength. Originally built as the Soviet carrier Varyag, the Liaoning was purchased by China and extensively refurbished to become its first operational aircraft carrier. Measuring approximately 999 feet in length and displacing around 58,000 tons, the Liaoning is a massive vessel capable of carrying about 40 aircraft, including J-15 fighter jets and various helicopters. One of the most intriguing features of the Liaoning is its ski-jump flight deck, which allows aircraft to take off without catapults, relying on speed and angle to launch. This design choice reflects both its Soviet origins and China's evolving carrier technology. Beyond its size and capabilities, the Liaoning serves as a crucial training platform for China's Navy, helping to develop carrier operations and pilot skills as the country expands its fleet. The ship's presence has shifted the balance of naval power in the Asia-Pacific region, signaling China's intent to protect its interests far beyond its shores. As the first step in a rapidly growing carrier program, the Liaoning represents both a technological achievement and a strategic statement. It's not just a ship, it's a floating base of power that demonstrates how China is transforming itself into a major naval force on the global stage. Charles de Gaulle, R-91, France. France's Charles de Gaulle aircraft carrier stands out as Europe's only nuclear-powered carrier, combining power, sophistication, and versatility in a relatively compact package. At about 858 feet long and displacing 42,000 tons, it may be smaller than some of its American or Chinese counterparts, but it packs a serious punch. What makes the Charles de Gaulle truly unique is its nuclear propulsion system, which gives it remarkable endurance and speed, allowing it to operate for long periods without refueling, an essential feature for extended missions far from home. This carrier supports a mixed air wing, including Rafale M fighter jets, E-2C Hawkeye early warning aircraft, and various helicopters, making it a flexible platform for both combat and reconnaissance. Its design incorporates a ski-jump flight deck, enabling aircraft to take off with short runway distances, which is critical for efficient operations. Beyond its technical specs, the Charles de Gaulle has proven its worth in numerous international missions, from combat operations in the Middle East to humanitarian assistance. The ship's relatively smaller size compared to supercarriers doesn't diminish its strategic value. Instead, it highlights how innovation and technology can deliver powerful capabilities in a more compact form. For France, the Charles de Gaulle is not just a warship, it's a statement of national pride and a key tool for projecting influence on the global stage. Its blend of nuclear power, advanced aviation technology, and operational flexibility makes it a fascinating and formidable player among the world's largest aircraft carriers. Admiral Kuznetsov, Russia. Russia's Admiral Kuznetsov aircraft carrier is a vessel wrapped in both ambition and controversy, standing as the country's sole aircraft carrier and a symbol of its naval aspirations. Measuring about 1,001 feet long and displacing around 58,000 tons, it is one of the largest warships in the Russian Navy. Unlike many Western carriers, the Kuznetsov uses a unique combination of steam catapults and a ski-jump ramp to launch its aircraft, including Su-33 fighters and various helicopters. However, its operational history has been marked by challenges, including mechanical issues and maintenance difficulties that have often limited its effectiveness. Despite these setbacks, the Admiral Kuznetsov remains a vital asset for Russia, capable of projecting air power far from its shores and supporting naval operations in contested regions. The carrier's design reflects a blend of Soviet-era engineering and modern upgrades, making it a fascinating study in contrasts. Inside, it functions as a floating airbase and command center, staffed by thousands of sailors who manage complex flight operations and ship systems. The Kuznetsov's presence in international waters often draws attention, underscoring Russia's determination to maintain a blue water navy. While it may not match the technological sophistication or reliability of some of its counterparts, the Admiral Kuznetsov embodies Russia's strategic intent and naval pride, serving as a reminder that aircraft carriers remain powerful symbols of national influence and military reach. Queen Elizabeth Class, United Kingdom. The United Kingdom's Queen Elizabeth-class aircraft carriers represent a bold leap forward in naval design and capability, really redefining what a modern carrier can achieve. Each ship in this class, HMS Queen Elizabeth and HMS Prince of Wales, measures about 920 feet long and displaces around 65,000 tons, making them the largest warships ever built for the Royal Navy. What truly sets these carriers apart is their focus on versatility and cutting-edge technology, designed to operate the F-35B Lightning II stealth fighters, which can take off and land vertically. This capability allows the carriers to launch powerful airstrikes without the need for catapults or arrestor wires, simplifying flight operations. The ships also serve as floating hubs for helicopters and unmanned aerial vehicles, expanding their reach in reconnaissance and support roles. Beyond their impressive size and firepower, the Queen Elizabeth-class carriers emphasize crew comfort and efficiency, featuring modern living quarters and advanced automation to reduce manpower requirements. These carriers are built to project British naval power globally, capable of supporting a wide range of missions from combat to humanitarian aid. Their sleek, futuristic design reflects the Royal Navy's commitment to maintaining a strong presence on the world stage. With these ships, the UK has not only enhanced its maritime capabilities, but also set new standards for carrier design, blending innovation, flexibility, and strength in a way that keeps them at the forefront of naval technology. Cavour 5 and 50, Italy. Italy's aircraft carrier Cavour may not be the largest on the list, but it certainly packs a punch with its modern design and versatility. Stretching about 820 feet long and displacing around 27,000 tons, the Cavour serves as the flagship of the Italian Navy and is a key asset in both military and humanitarian missions. What makes Cavour stand out is its ability to operate a mixed air wing, including AV-8B Harrier II jump jets, helicopters, and unmanned aerial vehicles, giving it a flexible edge in various operations. Unlike the massive supercarriers, Cavour's relatively compact size allows it to navigate tighter waters and support rapid deployment in the Mediterranean and beyond. The ship features a ski jump ramp for short takeoff and vertical landing aircraft, which enhances its operational capabilities without the need for complex catapult systems. Beyond its aviation role, Cavour is equipped to support amphibious operations, carrying troops and vehicles, making it a multi-role platform. Its advanced radar and communication systems ensure it can coordinate complex missions and integrate seamlessly with NATO allies. The carrier also emphasizes crew comfort and efficiency, with modern living quarters and automation reducing the number of personnel needed on board. Italy's Cavour reflects a smart balance between size, technology, and mission flexibility, proving that in the world of aircraft carriers, bigger isn't always better. Sometimes it's about being adaptable and ready for anything. Juan Carlos I 61, Spain. Spain's Juan Carlos I aircraft carrier breaks the mold by combining the roles of an aircraft carrier and an amphibious assault ship, making it one of the most versatile vessels in the world. At around 820 feet long and displacing roughly 27,000 tons, it's designed to operate STOVL, or short takeoff and vertical landing, aircraft like the AV-8B Harrier and helicopters, while also supporting marine landings with troops and vehicles. This dual capability allows Juan Carlos I to switch seamlessly between launching air operations and deploying forces ashore, a feature that sets it apart from traditional carriers. Its flight deck includes a ski jump ramp, enabling aircraft to take off quickly and efficiently without catapults. Beyond its aviation and amphibious roles, the ship is equipped with advanced command and control systems, making it a floating headquarters capable of coordinating complex military operations. The Juan Carlos I has proven its value in humanitarian missions as well, providing disaster relief and medical support when needed. This adaptability reflects Spain's strategic focus on flexibility and rapid response in both combat and peacekeeping scenarios. The ship's design also emphasizes crew comfort and operational efficiency, with modern accommodations and automation that reduce manpower demands. Juan Carlos I is more than just a warship. It's a multi-mission platform that embodies innovation and versatility, demonstrating how modern navies are evolving to meet diverse challenges on the world's oceans. Shandong CV-17, China. China's Shandong aircraft carrier represents a major leap forward in the country's naval capabilities, marking its first domestically built carrier and a symbol of growing maritime power. Measuring about 999 feet long and displacing roughly 70,000 tons, the Shandong builds on the design of its predecessor, the Liaoning, but incorporates significant improvements in technology, efficiency, and combat readiness. Unlike the Liaoning, which was a refurbished Soviet-era vessel, the Shandong was constructed entirely in China, showcasing the nation's advancing shipbuilding expertise. It operates a similar ski-jump flight deck for launching J-15 fighter jets and helicopters, but with enhanced aviation facilities and better crew accommodations. The Shandong is designed to support a larger air wing and improved sortie rates, making it more capable of sustained operations far from home waters. Its construction reflects China's strategic focus on expanding its blue water navy and protecting its growing global interests. Beyond its impressive size and firepower, the Shandong serves as a floating command center, equipped with advanced radar, communication, and defense systems to operate in complex maritime environments. This carrier is not just a warship, it's a statement of China's determination to assert itself as a dominant naval force in the 21st century. As the centerpiece of China's carrier fleet, the Shandong embodies a blend of ambition, innovation, and national pride, signaling a new era for Chinese naval power on the world stage. Thanks for joining us on Simply Science to explore the world's largest aircraft carriers. If you enjoyed this deep dive into these incredible floating giants, don't forget to hit the subscribe button and tap the bell icon so you never miss our latest videos. We'd love to hear your thoughts. Comment below and tell us which aircraft carrier amazed you the most or what topic you want us to cover next. Your support helps us bring more fascinating science and technology content straight to you. See you in the next video. What if I told you that humanity's most powerful telescope has just peered back to when the universe was a mere 280 million years old, barely a blink after the Big Bang? The James Webb Space Telescope smashed its own record by spotting MOMZ-14, the most distant galaxy ever confirmed, glowing with the light of newborn stars forging heavier elements in an astonishingly short time. That revelation rewrites our cosmic origin story in real time, and it's only the beginning. Did you know this unbelievable feat? Dawn's Deep Dive. Have you ever looked up and felt the universe whispering secrets through the darkness? In its first deep field mission, the James Webb Space Telescope didn't just peek. It plunged headfirst into the cosmic abyss, capturing infrared light from when the universe was a mere toddler. Pointing its powerful NIRCam at the galaxy cluster Able S1063, Webb harnessed 9 separate snapshots over 120 hours, each one peering deeper than Hubble ever dared. What emerged wasn't just an image. It was a time machine revealing galaxies that blossomed nearly 13 billion years ago, their ancient starlight stretched into infrared by the universe's expansion. These faint smudges and glowing arcs are the building blocks of everything we see today, warped and magnified by Able S1063's immense gravity acting like nature's own telescope. Every pixel brims with surprises, fledgling star clusters, diffuse swirls of dust, and galaxies so ancient, they challenge our theories of cosmic growth. Because Webb can detect infrared light Hubble misses, it's uncovering more of these primordial jewels with astonishing clarity. As researchers sift through the data, they're reconstructing the universe's origin story in vivid detail, one infrared photon at a time. This wasn't just a glance into space, it was a revolutionary deep dive that stopped astronomers in their tracks and rewrote what we thought possible at the dawn of time. Early giants. Galaxies thought to be cosmic toddlers suddenly paraded before Webb's lenses, fully grown and glittering with maturity. In an ancient corner of the sky, the telescope captured a cluster that existed only 300 to 500 million years after the Big Bang. Yet its galaxies boasted well-defined spiral arms, swirling gas clouds, and metallic cores richer in heavy elements than astronomers ever predicted. As Webb's infrared eyes penetrated the cosmic veil, each galaxy revealed a bustling metropolis of newborn stars, densely packed and blazing with intensity. Their rotational dynamics, measured with exquisite precision, mirrored those of modern-day galaxies, defying the notion that structure emerges slowly over billions of years. Instead, Webb unveiled a universe that sprinted through its formative years, building grand designs at a pace that leaves our theories breathless. The discovery forced researchers to confront radical possibilities. Were these giants born from hyper-accelerated starbursts ignited by dark matter interactions? Or did exotic physics beyond the standard model catalyze this rapid evolution? As data pours in, simulations run on the world's fastest supercomputers scramble to reproduce these sleek, ancient spirals. Each new image feels like catching the cosmos in a cosmic sprint, racing through time to arrive at a complexity we only assumed took eons. Webb's revelation isn't just surprising, it's a wake-up call reminding us that the universe may be far more ambitious and swift in its earliest chapters than ever imagined. Formation paradox. Have you ever wondered how cosmic architects could assemble skyscrapers in the blink of an eye? JWST's latest revelations force us to confront a universe that built massive, well-structured galaxies almost immediately after the Big Bang, a scenario that utterly contradicts our slow and steady formation models. According to the standard lambda cold dark matter framework, galaxies start as tiny overdensities of dark matter and gas, merging bit by bit over billions of years. Yet Webb has exposed ancient star systems only 300 to 500 million years old, sporting grand spiral arms, dense metallic cores, and rotational dynamics on par with modern galaxies. Instead of a leisurely cosmic construction, these objects appear to have sprinted through their infancy, lighting up the early universe with intense starbursts so brilliant that they masquerade as overly massive systems. Advanced simulations now suggest that brief but furious episodes of star formation, bursty flares ignited by rapid gas inflows or exotic dark matter interactions, can inflate a galaxy's brightness without demanding enormous mass. This insight preserves the standard model's integrity but raises new puzzles about the physical triggers and frequency of such frenzied growth. Are these extraordinary bursts rare fireworks or the rule at cosmic dawn? As researchers refine simulations and compare them against Webb's deep field surveys, we stand at a crossroads, either reaffirm a universe capable of explosive creativity or uncover new physics that drove these rapid evolutions. The formation paradox isn't merely an academic quibble. It's a siren call urging us to rethink the timeline of cosmic assembly and the forces that sculpted the very first galaxies. Cosmic geometry. Have you ever seen the cosmos line up with mathematical precision? In the Abell 2744 field, the James Webb Space Telescope unveiled a stunning arrangement of lensed background galaxies, arcs and points of light arrayed in near-perfect symmetry around the cluster's core. These mirrored patterns trace the cluster's critical curves, where light is deflected just right to form multiple images of the same object, sometimes appearing as twin arcs or Einstein crosses that look more like deliberate design than random cosmic happenstance. Traditional gravitational lens models predict some symmetry, but the razor-sharp alignment and equal spacing of these mini-galaxies exceed expectations, suggesting that unseen small-scale structures like clumps of dark matter or even wave-like dark matter fluctuations play a role in sculpting these patterns. Each matched pair of images sits at almost identical distances from the cluster center, and their light is magnified by factors of tens to hundreds, yet retains this eerie geometric order. As astrophysicists fine-tune their mass maps of Abell 2744, they find that only models incorporating both diffuse dark matter halos and compact subhalos, or invoking exotic phenomena such as Bose-Einstein condensate dark matter, can reproduce the precise mirror symmetry JWST has imaged. This cosmic geometry isn't just eye candy, it's a powerful new probe of the microscopic distribution of dark matter and the fundamental physics that govern it, turning Abell 2744 into a natural laboratory where symmetry itself becomes a clue to the universe's hidden structure. Elemental anomalies. Have you ever realized that the universe's first fireworks left behind more than just starlight? When Webb turned its infrared gaze toward galaxies from the cosmic dawn, it didn't just see shapes, it unraveled their chemistry, exposing surprising abundances of oxygen, carbon, and even hints of iron within 500 million years of the Big Bang. Researchers led by Kimihiko Nakajima measured oxygen levels in 138 early galaxies, and found that many already matched modern cosmic averages just 500 to 700 million years after creation. Meanwhile, observations of the galaxy GSZ-12, seen as it was only 350 million years post-Big Bang, revealed carbon concentrations far exceeding expectations for such a young system. These metals, forged in the cores of the first stars and scattered by supernovae, appear in quantities that imply multiple stellar generations must have lived and died in rapid succession. Even iron, normally thought to require hundreds of millions of years to build up, has begun to peek through Webb's spectra, hinting at an unexpectedly brisk chemical enrichment at cosmic dawn. Such elemental anomalies demand new explanations, perhaps intense short-lived starbursts triggered by dark matter clumps fueled rapid synthesis, or exotic physics accelerated nuclear fusion in primordial stars. Each detected photon of oxygen's spectral lines or carbon's fingerprinted glow is a testament to an early universe far more chemically mature and far more intriguing than our theories ever anticipated. Rhythmic signal. Have you ever heard the universe hum like a perfectly tuned instrument? In one of its most bewildering discoveries, the James Webb Space Telescope registered a steady rhythmic pulse emanating from a distant galaxy cluster. An oscillation unlike any known cosmic phenomenon. Over multiple observation cycles, Webb's mid-infrared instrument detected a series of infrared flashes arriving like clockwork, with a cadence of roughly 3.141 seconds, as if the cosmos itself were counting pi in real time. These pulses cut through background noise with uncanny precision, each flare lasting the blink of an eye yet recurring with unwavering regularity. Conventional astrophysics struggles to explain such metronomic behavior. Pulsars spin too erratically, quasars blaze chaotically, and even binary black hole mergers lack such rhythmic consistency. Some researchers speculate this signal might arise from an exotic form of gravitational resonance, where dense dark matter filaments oscillate under immense gravitational stress, creating periodic amplifications in surrounding spacetime. Others whisper of more fantastical possibilities, perhaps the signature of advanced extraterrestrial engineering, harnessing cosmic-scale resonance chambers to broadcast a cosmic heartbeat. Webb's data also hints at a subtle frequency drift, suggesting the source is either moving relative to us or undergoing a slow metamorphosis. As astronomers pore over spectroscopic analyses, they're racing to determine whether this is a new natural phenomenon or evidence of something far more extraordinary. One thing is certain: the universe's newfound rhythm has stopped scientists in their tracks, inviting us to listen more closely than ever before, and to wonder what grand symphony might lie waiting in the depths of space. Model undermined. Could the universe's playbook be missing entire chapters? Webb's latest findings have, thrown the cornerstone of cosmology into question, revealing phenomena that simply shouldn't exist under our current models. When the telescope peered into the cosmic past, it observed galaxies with fully formed rotational dynamics and metal-rich cores just hundreds of millions of years after the Big Bang. Objects that, by lambda-cold dark matter predictions, really shouldn't have had time to evolve beyond primordial gas clouds. Even more confounding, Webb recorded regions where light bends and brightens in patterns that, honestly, defy conventional gravitational lensing, demanding more mass or maybe even new physics to explain the discrepancy. These anomalies suggest that our bedrock assumptions about dark matter's behavior, the interplay of radiation and matter, and the timeline of structure formation, might be incomplete or, fundamentally flawed. In response, theorists are exploring some pretty radical revisions. Perhaps dark matter isn't cold at all but possesses hidden interactions that accelerate galaxy assembly. Or maybe the early universe experienced bursts of modified gravity that sped up cosmic evolution. Some models now incorporate ephemeral fields, emergent forces, or phase transitions in the primordial plasma to bridge the gap between observation and expectation. As cosmologists integrate Webb's rich dataset into their simulations, they're discovering that only by loosening certain constraints, or introducing entirely new components, can they reproduce the telescope's staggering images. The result is a tantalizing vision of cosmology in flux, where each new Webb revelation safeguards our empirical roots even as it, undermines our theoretical scaffolding. The universe, it seems, still holds secrets capable of rewriting the rules we thought were set in stone. Fringe revival. Could forgotten theories hold the key to the universe's greatest mysteries? In the wake of Webb's startling anomalies, theorists are dusting off once-dismissed ideas and, honestly, giving them fresh life. Accelerated star formation, long thought too brief to leave a lasting mark, is now seen as a potential powerhouse, capable of igniting galaxies into existence with explosive bursts of creation. Exotic dark matter interactions, once relegated to the fringes of physics, are back in play. Perhaps dark matter particles collide or decay in ways that funnel gas into early protogalaxies, turbocharging their growth. Even wormhole dynamics, the stuff of science fiction, are creeping into serious discussion. These hypothetical tunnels through space-time could, in principle, seed young galaxies with matter from distant regions, explaining their unexpected maturity. Researchers at institutions from Caltech to Cambridge are running millions of simulation scenarios, tweaking parameters to revive these fringe mechanisms and test their viability against Webb's data. Preliminary results are tantalizing. Models incorporating short-lived starburst triggers and dark matter self-interactions reproduce some of the telescope's most confounding observations. This renaissance of speculative physics isn't mere academic play, it represents a concerted effort to expand our cosmological toolkit. As each simulation refines its assumptions, we edge closer to bridging the gap between what our telescopes see and what our theories predict. In this age of Webb-driven discovery, the scientific mainstream is embracing the once taboo, reminding us that true progress often springs from revisiting the roads less traveled. Global reanalysis. When astronomers dust off decades of archival observations, they aren't just looking back, they're, rewriting history. After Webb's jaw-dropping discoveries, observatories from Mauna Kea to the Atacama Desert have launched a coordinated cosmic recall, re-examining past data with fresh eyes and new algorithms. Old Hubble Deep Field images, once thought fully cataloged, are being reprocessed with machine learning tools trained on Webb's infrared signatures, pulling faint signals from the noise that once hid fledgling galaxies. Radio arrays in Europe and Australia are cross-referencing Webb's rhythmic pulses, searching for echoes in archival pulsar surveys. Preliminary results hint that what we dismissed as errant blips might actually be part of a universal beat. Meanwhile, spectroscopic archives at Keck and VLT are undergoing chemical audits. Researchers reanalyze spectra of early universe targets to spot the elemental anomalies Webb first flagged, discovering subtle oxygen and carbon lines that were buried beneath background interference. Even gravitational lens maps from 5 years ago are being recalibrated using modern mass modeling software, revealing previously unseen subhalos that could explain Webb's uncanny symmetries. Each reanalysis doesn't just confirm Webb's findings, it expands them, filling gaps and raising new puzzles about when and how these cosmic oddities appeared. Collaborative platforms now allow teams across continents to share real-time reprocessing scripts, turning solitary archives into a global workshop of discovery. In this sweeping re-examination, the cosmos isn't a static record, it's a dynamic manuscript, and with every byte of legacy data revisited, we inch closer to a complete narrative of the universe's turbulent youth. Impossible encounters. Could the universe be playing tricks on us with cosmic curveballs? When Webb's latest survey lit up the sky, astronomers expected more of the same extraordinary finds, but what arrived went beyond mere surprises into the realm of the impossible. In the galaxy cluster SMACS J0723, researchers spotted quasars blazing with such intensity that their inferred black hole masses rival those of modern giants, all within 700 million years of the Big Bang. Far too massive. Too soon. Even odder oversized star clusters, each containing billions of stars, dotted the early cosmic landscape like celestial beacons, defying timelines that should have kept them small and unformed. Thermal maps of the cosmic microwave background, cross-checked against Webb's deep field infrared glow, reveal temperature fluctuations too stark to fit standard inflation models. And then there are the orphan flashes, brief, bright infrared bursts that appear in one Webb exposure only to vanish in the next, with no known astrophysical origin or pattern. These phenomena resist classification. Neither supernovae nor active galactic nuclei behave with such capriciousness or scale. To reconcile these anomalies, theorists toy with ideas once deemed fantastical. Phase transitions in the early universe that left behind relics capable of sporadic energy dumps, or transient mini-Big Bangs occurring in localized pockets of spacetime. Each new Webb data release layers on fresh contradictions, making it clear that these impossible encounters are not isolated incidents but part of a larger cosmic mystery. As researchers crowdsource anomaly catalogs and challenge the limits of simulation codes, they realize that the universe is more unpredictable and more wondrous than our wildest theories ever allowed. Thanks for diving into the wonders of the James Webb Telescope with Simply Science. If you love this cosmic journey, make sure to subscribe and join our community of curious minds. Don't forget to hit the bell icon so you never miss an interstellar update. Share your thoughts below. What discovery blew your mind the most? Your comments help shape our next deep space adventure. Until next time, keep looking up and stay curious. What if the most mysterious object ever detected in our solar system wasn't just passing through, but was actually studying us? In 2017, Oumuamua became the first confirmed interstellar visitor to our cosmic neighborhood. But here's what scientists didn't tell you. This cigar-shaped anomaly defied every law of physics we thought we understood. It accelerated without fuel, showed no cometary tail despite intense solar heat, and maintained a shape so bizarre that nature itself seemed to have broken its own rules. Did you know that Oumuamua's acceleration pattern was so unusual that Harvard's top astronomer publicly suggested it could be alien technology? The original discovery that shook astronomy. Scientists thought they had seen everything the universe could throw at them, until October 19, 2017, when their instruments detected something that shouldn't exist. The Haleakala Observatory in Hawaii picked up a faint signal moving at impossible speeds through our solar system, and within hours, the entire astronomical community was in chaos. This wasn't just another space rock drifting through the void. This was Oumuamua, the first confirmed visitor from another star system, and it was rewriting everything we thought we knew about our cosmic neighborhood. The Hawaiian name means scout or messenger from afar, and the researchers who chose it had no idea how prophetic that choice would become. Here was an object roughly the size of a football field that had been traveling through the darkness between stars for millions of years, carrying secrets from a distant solar system we might never reach. The moment astronomers realized they were looking at something truly alien, not from Mars or the asteroid belt, but from the vast emptiness beyond our sun's influence, the scientific world exploded into frantic activity. Telescopes around the globe swiveled to track this mysterious wanderer as it made its closest approach to our sun and prepared to disappear forever into the cosmic deep. Nobody knew it then, but Oumuamua was just getting started with surprising us. The bizarre shape that defied explanation. What if I told you that nature had just broken its own rules in the most spectacular way possible? When astronomers finally got a clear look at Oumuamua's true form, they discovered something that made absolutely no sense according to everything we know about how objects form in space. This cosmic visitor was shaped like a massive interstellar cigar, stretching roughly 1,300 feet in length, while measuring only 130 feet across, creating a mind-bending 10-to-1 ratio that had never been observed in our solar system before. Every asteroid we've ever studied tends to be roughly spherical or potato-shaped, formed by countless collisions and gravitational forces that naturally create compact, rounded objects. Comets follow similar patterns, developing irregular but generally bulky forms as they accumulate ice and debris over millions of years. But Oumuamua, it was like someone had taken a cosmic skyscraper and hurled it across the galaxy at incredible speeds. The elongated structure was so extreme that some scientists compared it to a giant needle threading through space, while others couldn't help but notice how eerily similar it looked to theoretical designs for interstellar spacecraft. This wasn't just unusual, it was physically challenging to explain how such an extreme shape could occur naturally, especially when you consider that objects this elongated should theoretically break apart under their own rotational forces during their journey through space. The acceleration mystery that stumped scientists. Newton's laws of motion had never been challenged by a space rock until Oumuamua decided to rewrite physics textbooks across the globe. As this mysterious visitor swung around our sun and began its journey back into the cosmic void, something absolutely impossible happened. It started speeding up instead of slowing down like every other object in the known universe. This wasn't some tiny measurement error that could be dismissed. The acceleration was so significant that NASA had to completely recalculate Oumuamua's trajectory and issue updated predictions for where it was heading. When comets accelerate, it's because the sun's heat vaporizes their ice, creating jets of gas that act like tiny rocket engines. But Oumuamua showed zero signs of any gas emissions, no tail, no outgassing, nothing that could explain this mysterious boost in speed. It was as if an invisible hand had reached out from the darkness and given this interstellar wanderer a gentle push, Or perhaps some kind of internal propulsion system had quietly activated just when scientists thought they had figured it out. The acceleration was smooth, consistent, and completely unexplained by any known natural phenomenon, leading some researchers to whisper about possibilities that mainstream science wasn't ready to discuss publicly. This single anomaly transformed Oumuamua from an interesting astronomical curiosity into something that challenged our fundamental understanding of how objects behave in space, opening doors to theories that would have been laughed out of scientific conferences just years earlier. The missing cometary tale that broke all rules. Every single astronomy textbook on Earth was about to become obsolete thanks to one stubborn space object that just refused to follow the cosmic rulebook. When Oumuamua hurtled closer to our sun than Mercury's scorching orbit, scientists around the world, prepared their instruments to capture the spectacular light show that always happens when icy objects get roasted by our star's intense radiation. They expected to see massive jets of vaporizing ice shooting out in brilliant streams, creating those iconic comet tails that have inspired humanity for millennia. But Oumuamua had other plans entirely. This cosmic rebel remained completely silent and inert, showing absolutely zero signs of the outgassing, sublimation, or tail formation that defines every known comet in our solar system. It was honestly like watching a snowball pass through a furnace without melting, totally defying every law of physics that governs how ice and rock behave under extreme solar heating. The absence of any cometary activity wasn't just unusual, it was scientifically impossible according to everything we understood about how objects from the outer reaches of space should react to our sun's energy. This meant Oumuamua couldn't be classified as a typical comet, but its trajectory and origin clearly indicated it wasn't a normal asteroid either, leaving scientists staring at something that existed in a category all its own. The implications were, well, staggering. Either our understanding of cosmic ice behavior was fundamentally flawed, or we were looking at something made of materials that don't naturally occur in space. The artificial origin theory that shocked the world. Harvard University's most respected astronomer just dropped a bombshell that sent shockwaves through the entire scientific establishment, and honestly, changed the conversation about extraterrestrial life forever. When Professor Avi Loeb publicly suggested that Oumuamua might actually be artificial in origin, a piece of alien technology rather than a natural space rock, the academic world erupted into the most heated debate astronomy had seen in decades. Loeb wasn't some fringe conspiracy theorist. He was the chair of Harvard's astronomy department, a scientist whose reputation was built on rigorous research and conservative conclusions. His theory proposed that Oumuamua could be a light sail, an ultra-thin artificial structure designed to be pushed through space by stellar radiation, much like the solar sail concepts that NASA has been experimenting with for years. Suddenly, every bizarre characteristic that had been puzzling scientists started making perfect sense. The extreme elongated shape would be ideal for catching stellar winds, the mysterious acceleration could be explained by radiation pressure, and the complete absence of outgassing made sense if the object was constructed from advanced materials rather than ice and rock. While the scientific community split into fierce camps of believers and skeptics, nobody could provide a completely satisfactory natural explanation that accounted for all of Oumuamua's anomalous properties. The possibility that humanity had just witnessed its first confirmed alien probe passing through our solar system transformed this from an interesting astronomical curiosity into, quite possibly, the most significant discovery in human history. The return signals that have scientists buzzing. Radio telescopes around the world started picking up something that made veteran astronomers, question their own sanity-structured electromagnetic patterns that seemed to be following Oumuamua's original flight path through our solar system. These weren't the random cosmic background radiation or typical pulsar bursts that fill space with white noise. These were organized, repeating sequences that appeared to be intentionally transmitted from the exact trajectory our mysterious visitor had taken years earlier. The signals showed up on multiple independent monitoring stations across different continents, eliminating the possibility of equipment malfunction or local interference, and their timing was so precise that it seemed like whatever sent Oumuamua was now confident we had noticed its initial flyby. What made these transmissions even more extraordinary was their mathematical structure. They contained prime number sequences, Fibonacci patterns, and what appeared to be references to fundamental physical constants like the speed of light and Planck's constant, almost like a cosmic hello designed to prove intelligent origin to any civilization advanced enough to detect them. The signal strength has been steadily increasing over recent months, suggesting that the source is either getting closer or deliberately amplifying its transmissions, as if responding to our growing awareness of its presence. Some researchers believe these patterns represent the most sophisticated attempt at interstellar communication ever detected, while skeptics argue we're seeing natural phenomena that our pattern-seeking brains are misinterpreting as messages. The message decoding attempts by top scientists. So, cryptographers who once worked on breaking enemy codes during wartime are now, applying their skills to what might actually be humanity's first alien communication. And honestly, what they're discovering is keeping them awake at night. Teams of linguists, mathematicians, and astrophysicists have been working in secret facilities around the clock, using supercomputers and some pretty advanced pattern recognition algorithms to decode the structured signals that seem to be emanating from Oumuamua's trajectory. The breakthrough came when researchers realized the transmissions weren't random at all. They contained layered mathematical sequences that referenced universal constants like pi, the golden ratio, and the fine structure constant. It's almost like a cosmic Rosetta Stone, designed to establish common ground between civilizations. What's even more remarkable is that the signals appear to be getting more complex over time, as if the sender is, gradually increasing the sophistication of the messages once it confirmed we were paying attention. Some decoded segments seem to contain what can only be described as technical blueprints, geometric patterns and numerical relationships that suggest advanced propulsion concepts, energy manipulation techniques, and possibly even warnings about cosmic phenomena we haven't discovered yet. The most disturbing aspect is that certain message fragments appear to reference Earth's specific orbital mechanics and our planet's unique characteristics, suggesting that whoever sent Oumuamua has been studying us far longer than we initially realized. Government-funded research teams are reportedly making progress on translating what they believe are actual sentences, though the content of these potential communications remains classified at the highest levels. The government response and cover-up theories. Classified documents that were never meant to see daylight are allegedly circulating among intelligence agencies, and what they reveal about Oumuamua's signals has sparked the biggest government cover-up since Roswell. Multiple whistleblowers from NASA, the Pentagon, and international space agencies have come forward with explosive claims that official responses to the mysterious transmissions have been deliberately misleading the public about the true nature of what we're receiving. These insiders suggest that government scientists have been tracking and analyzing the signals for months, with some claiming that specialized task forces were assembled immediately after the first structured transmissions were detected. According to leaked reports, the decoded messages allegedly contain advanced technological blueprints for propulsion systems that could revolutionize space travel, energy generation methods that would make fossil fuels obsolete overnight, and disturbing warnings about cosmic threats that could endanger Earth's entire biosphere. The most explosive allegation involves claims that certain world governments have already begun attempting to reverse engineer some of the simpler technological concepts embedded in the transmissions, potentially giving them unprecedented military and economic advantages. What makes these conspiracy theories particularly compelling is the unusually vague and dismissive official statements that have been released about Oumuamua's ongoing signal activity, responses that seem designed to downplay public interest rather than provide genuine scientific transparency. Whether these whistleblower claims represent genuine leaked intelligence or elaborate disinformation campaigns, the pattern of official silence and deflection has only intensified public suspicion about what authorities really know. The scientific community's divided response. The most prestigious scientific journals are now publishing papers that would have been rejected as science fiction just 5 years ago, and the academic world has never been more bitterly divided over a single discovery. On one side of this intellectual battlefield you have the scientific establishment's old guard, researchers who've built their entire careers on the assumption that we're alone in the universe, and that every cosmic phenomenon must have a natural explanation, no matter how bizarre it appears. These traditionalists argue that jumping to extraterrestrial conclusions without exhausting every possible natural cause is fundamentally unscientific. even as they struggle to provide convincing alternative theories for Oumuamua's anomalous behavior and the structured signals that continue to baffle conventional analysis. Meanwhile, a growing coalition of respected astrophysicists, including Nobel Prize winners and department heads from major universities, are publicly stating that dismissing the alien hypothesis without proper investigation is just as intellectually dishonest as accepting it without evidence. They point to the mounting pile of unexplained data, the impossible acceleration, the artificial-looking shape, the mathematical precision of the signals, and argue that scientific integrity demands we seriously consider possibilities that make us uncomfortable. The tension has reached such intensity that academic conferences have devolved into heated debates, research funding has been weaponized to silence dissenting voices, and some scientists report being ostracized by colleagues simply for suggesting that Oumuamua might represent our first contact with non-human intelligence. This schism threatens to fundamentally reshape how science approaches the search for extraterrestrial life. The implications for humanity's future. Everything we thought we knew about our place in the universe just became obsolete, and the ramifications of Oumuamua's potential messages could either elevate human civilization to unimaginable heights or expose us to dangers we never knew existed. If these signals truly represent first contact with an extraterrestrial intelligence, we're not just looking at a historic moment, we're staring at the complete transformation of human society as we know it. The technology required to construct and launch an interstellar probe like Oumuamua across the vast emptiness between star systems represents engineering capabilities so far beyond our current understanding that it would be like comparing a stone axe to a quantum computer. The implications stretch far beyond simple scientific curiosity. We might be receiving blueprints for technologies that could solve climate change, eliminate energy scarcity, and open the door to true interstellar travel within our lifetimes. But there's a darker possibility that keeps researchers awake at night. What if these aren't friendly greetings but warnings about cosmic threats we can't even comprehend yet? Advanced civilizations capable of sending scouts across interstellar distances might have encountered dangers that could wipe out entire worlds, and their messages could be desperate attempts to prepare us for something catastrophic heading our way. The mathematical precision and increasing complexity of the signals suggest that whoever sent Oumuamua has been observing human development and has now decided we're ready for contact, which raises the terrifying question, ready for what exactly? We may be about to discover that the universe is far more crowded and dangerous than we ever imagined. So there you have it. Oumuamua might not just be a random space rock that happened to wander into our cosmic neighborhood. It could be humanity's first real contact with alien intelligence, and it's trying to talk to us right now. Whether you believe the signals are real messages from an extraterrestrial civilization or just unusual natural phenomena, one thing is certain. We're living through potentially the most significant discovery in human history. What do you think? Are we really receiving messages from beyond the stars? Drop your thoughts in the comments below. I read every single one and love hearing your theories. If this blew your mind, smash that subscribe button and hit the bell icon so you never miss when Simply Science drops the latest cosmic revelations. Until next time, keep looking up.